Hey everyone, this is a video on the first section of chapter 3. So one thing I want to say is that chapter 3 covers 4 sections and we spend more time on the later 2 sections, which could have a lot of new applications with interest rates, payments. We do amortization, savings bonds, and some of you might find this information interesting and useful. Okay. So for this first section, we'll talk about simple interest just to get some of the terminology down. So this chapter is a study of mathematics, of compound and simple interest. Understanding the basic mathematics of finance can equip you. Very useful for the future, especially when you're making decisions. To use these tools, you will need a calculator, so make sure you have a calculator or you use Desmos. Throughout this chapter, interest rates are to be converted to decimal form before you use them in a formula, and if you get the rate out of the formula, then you have to convert it to the percentage. Okay, so just be aware of that. So the first thing we'll talk about is simple interest. And this is usually for short-term debt. The concept of simple interest will be talked about in 3.1. So when money is deposited into a savings or borrowed from a lender, the amount deposited or borrowed is called the principal. And usually we denote that with a P. And then the fee charged for the use of money is typically the interest. Interest is usually computed as a percent of the principal over a given time period. Right? And unless otherwise stated, the interest rate is an annual rate. So we have 2 formulas here. So this is just simple interest, that the interest equals your principal times the rate times the time in years. Okay. So let's look at this first example here. Compute the interest on a loan of $500 at 8% for 6 months. So you want to think your principal is here. It's 500. Your percentage. This is your rate, but not in decimal form. So you want to think 8% is 0.08 for your decimal form. So pretty much we divide by 100. So if you have a percent, to make it the decimal form, divide by 100. If you have decimal form and you want to convert it to a percent, you're going to multiply by 100 and add a percent for that. So let's compute the interest. So I would equal principal times rate times time. So your interest in this problem will be 500 times 0.08, and then your time. So 6 months is your time here, but I need to put it in years. So 6 months, to convert it to years, typically you divide by 12 because 12 months are in a year. Right? So 6 months would be 1.5 years. Right? So if you have something in months and you want to convert it to years, you just divide by 12. So if you multiply all that out, so get your calculator or use Desmos, 500 times 0.08 times 1 divided by 2, and I get 20. So check this. So in this problem, $20 would be the interest that you owe. Okay. Now let's say a lot of people want to know, I don't want to know the interest I owe, but what's the total amount? Let's say if I take a loan for so much money, how much am I going to have to pay back all together in the end? And this is where we get this other theorem, where A is the amount or future value, P is the principal or present value, R is the same as before, and T is the time in years. So some books and resources will say future value is FV and present value is PV. Okay, so just be aware of that. So the same one here, I want to know what's the total amount of the loan of $800 at 9% simple interest at the end of 4 months. So we have our principal. We have, this is our R, but remember, this would be 0.09 because you divided by 100 or move the decimal 2 places to the left. right? So some people see it as the decimals here, 1, 2. So it would be 0.09 is your rate. And then 4 months. So 4 months is 4 divided by 12 years, or 1/3 of a year. Okay. So plug it in our formula. You'll see here it's your principal plus your interest. So this is the shortcut. You factor out that P. So A would equal P times 1 plus RT. Right? So let's plug in everything. So A would equal 800 times 1 plus 109 times 1/3. So let's key that in our calculator and see what we get. $824. So that's how much we would owe altogether. If we took a loan out for $800, and this is the interest that we were decided on the rate, and we have to pay it back in 4 months, this is how much we have to pay back. Okay. So make sure you understand these two formulas. So you have a match problem 1 you could try. Okay. You have a match problem 2 here, but let's talk about this first example. So present value of an investment. So let's say you want to earn 10% on your investment. How much would you need to deposit for a note to be worth $5,000 in 9 months? So you want it to be worth. So this is the future value you want it to be worth. So this is your A, or your future value. Right? So remember, we're going to use this formula here. I want the rate to be 10%, so this is my R, and remember this would be as a decimal, 0.10. And I want my time to be 9 months. So 9 months is 9/12 of a year, because there are 12 months in a year. So let's plug all that in. So A is 5,000, because that's how much I want in the future, and I'm asking for how much should I invest now. P, I don't know. And then 1 plus your rate. And then 9/12, or we could say this is 3/4. And you'll notice that this whole thing is being multiplied to P. So I can divide it over. So P would equal 5,000 over 1 plus. So P would equal 5,000 divided by, let's figure out what the denominator is first, because that's a lot in your denominator. So just type that denominator part in Desmos, see what you get. And then let's divide the two. So 4,651 and 16. So I'm rounding to the nearest cent. So I have to deposit $4,651 if I'm going to earn an annual rate of 10% back. Okay. So you can practice with math problem 2. I would say the hardest part with a lot of this stuff is just keying things in correctly. So re-practice these on Desmos, your calculator. Make sure you can get the right calculations. So one thing to note is that some of the problems use a banker's year. A banker's year is 365. Not 365, 360, not 365. Okay. So other times, the number of days is, I was reading the 365 here. Okay. So the choice will always be clearly stated, like in your mini project and your project. It'll specifically state banker's year. So let's look at an example. So treasury bonds. We have, suppose, a 180-day treasury bond T-bill with a maturity value. So that's what the future value will be. It's going to mature. So you can think of this as your future value. Mature, that means it's going to grow to that point. and then we purchased it for this. So this is kind of your present value. This is how much we purchased it for. What annual simple interest rate can be earned, okay? So if we think about it, this is using this formula here. And what we don't know is we don't know this. We don't know the rate, okay? So there's a few ways you can solve this. I'm just going to plug everything in, and then we'll solve accordingly. Now, in your notes, they might have, or in your book, I should say, if you factor the P out here, so if we factor the P out, we get this. And then if I subtract over this first P, I get A minus P equals RT, and then divide by PRT, divide by PT. And then I get that your R would equal A minus P over PT, which is perfectly fine to do. And for your project, I do stress this. Okay, so we could do it this way just to see how it works, okay? As I said in the beginning of this course, there are many different ways to do these problems. Now, one approach is just to use this formula here without trying to manipulate anything, plug in everything, and then solve for R. And I think in the mini project video, I do it that way. So let's look at this other way in case you might be more comfortable with this. So we have our A, which is 10,000. We have our P, which is 9,893.78. And then we have a P again at the bottom. And then we multiply that to T. So this says it's 180 days. So that would be 180 over 360. So if I simplify all this, I do the top part first. So that gives me this on top. I do the denominator part. I get this. I divide the two. And I get 0.2147, right? 2. And this is your decimal form. So remember, I need to convert to a percent. So this would be, I just move the decimal 2 places to the right or multiply by 100. So 2.1472%. Okay. And this says round to 3 decimal places, so I can just take off this last 2 because it's not going to change the 7 or anything. Right? So the last problem that we'll talk about is this note problem. So we see here that I'm buying a new car and you decide to sell your old car. So you take a 270-day note for this much at this % interest as payment. Okay. The principal plus the interest due at the end of this. Okay. So you're selling that old car. This is the note. It's for this much, and you're going to earn some interest. So 60 days later, you need money. So you sell the note to a third party for this much. Okay. What will the annual interest rate the third party receive for the investment? So there's a similar one on the mini project, so you can always look at that one as well, but we'll go through this one. So first thing you have to do is, for the original part here, is what is the future value, or A, on the 270-day note. So let's compute that first. So we have A equals, the note is for 3,500. The interest rate is 10%. And the time is 270 over 360. So we compute all this in our calculator. So just multiply it out, see what you get. So practice that you can do this on Desmos or your calculator. And I come to 3,762.5. You'll see that we're not done here, but the match problem has a very similar thing. Okay. And then you can I'll tell you what you need to change in a second for the match problem. So we have our A. So this is how much, the future value would be on this note. So let's say later, I want to sell this note 60 days in the future, that I'm selling it for this. So you want to think now, instead of at 3,500, it's a different value that I'm selling it at. I want to get what's the new rate going to be for what is the annual interest rate will the third party receive for the investment. So this third party is purchasing the note that, right, for this. So what interest rate will that third party receive? Okay, so we're going to use this as our new future value. This is our new present value. Okay, I don't know what R, but the T is what? So if it's 60 days later and I have how many days technically are left to pay off this note? If there's 270, I take away the 60, I get 210. So it's 210 over 360. Okay. So we can use that formula for above, that your rate would equal A minus P over PT. So let's plug everything in. Our A is still the same. Our new P is what the note was purchased at by the third party. And my T is now the smaller number of days. Right. So I'm just going to compute what this is. Right. So on top, I get 212.5. On the bottom, I get 0.583 repeating. So I'm going to divide these two. Oh wait, the denominator is not that. Let me correct myself. I forgot to do the 3,550. So 3,550 times the 210 divided by 2. So my mistake there. So this would be 2,070.83. Now let's divide these two. So we divide them, we get 0.126, 0.102615.6. And then I need to, move it 2 places over. So I get 10.26%. So that is the new rate. This says to 3, so I'll erase that percent sign and add another placement. 2. So you see that this third party, the rate went up a little bit above the original. Okay. So I hope you enjoyed this video. The rest of the examples don't really have anything to do with your homework, but one thing to note is if you're practicing right here for this match problem 4, there is a typo. This should be 350 for how much they're going to purchase the note for. Okay. And none of the other problems we will talk about because you don't have any homework questions related to these. So I hope you enjoyed the video. Look out for the next one. Thanks.